The best thing about being a first.
Good afternoon, everybody. Welcome to you all for joining us here at the RSN Spring Conferences presented by WPI. I'm your host, Francis O'Rourke, and joining me this afternoon to talk about how to use Onshape, how to optimize your FRC design workflow in Onshape is Marcus Bernstein. Marcus, why don't you tell us a little bit about yourself?
Hi, everyone. My name is Marcus Bernstein. I'm a current mentor of Team 7599 from Cristo Rey High School. I founded MKCAD a couple years ago and have been pretty involved in the Onshape effort within FRC. I'm glad to be here. Thanks, Francis.
Yeah, well, I'm glad you're here. I know my team, we used Onshape for a while. I know a lot of other teams have used Onshape. I'm not a CAD person myself. I am generally stymied by it, but I know that it's a fantastic tool that I hope more teams get to utilize. And so thank you for being here. If you're watching this live and you have a question for Marcus, please type your question into the chat. We want to hear from you. Type !Q followed by your question. We'll take those questions, pick them out of the chat, and we'll answer them here live on air. We'll do some questions as we go and also questions at the end as well for anybody. And so last but not least, I want to, of course, thank WPI for helping to make this all possible. WPI is a leader in project-based education, and they were the first university to offer a Bachelor's of Science, a Master's, and a PhD program all in robotics engineering. If that sounds interesting to you, or if you want to maybe become a student at WPI, or if you want to sponsor one of the projects that WPI hosts every year, you can learn more about it all at wpi.edu. All right, well, with that out of the way, Marcus, why don't you give us a little tour of what Onshape and how it all works?
Thanks, Francis. So again, my name is Marcus Bernstein, and today I'm going to be talking to you guys about optimizing your FRC design workflow in Onshape. As Francis introduced, this is the RSN Spring Conferences presented by WPI. I want to also thank RSN and WPI for hosting this. It's a great opportunity, and I'm glad to be here.
Well, we're glad you're here as well.
Thank you. Tonight's webinar or conference going to be pretty simple. I'll do a quick intro of like myself and who I am and like my qualifications to be talking at all of you right now. I'm going to talk about the teams organization within Onshape. I'll highlight MKCAD configurable parts. I'll highlight some feature scripts that were made specifically for FIRST to make your life easier. And then I'm going to do a demo of how I would create a West Coast drivetrain in Onshape. That demo is going to highlight a lot of those elements from MKCAD of those feature scripts. And that's a great opportunity for folks to ask questions about how I'm doing things and why I'm doing them. And then I'm going to leave a lot of time for Q&A. That'll be a great opportunity, again, for folks to ask those questions, figure out how I would do the types of things that you guys are trying to do in Onshape, as well as so that Q&A can be live demo in Onshape or just answering questions about Onshape workflow or whatever else people want to ask about. A little bit about me, again, Marcus Bernstein. I'm an alum from FRC Team 1836, as well as FLL Team 2890. I've been doing this for a while. I'm currently a mentor of Team 7599, Alpha Blue from Cristo Rey High School. I'm also the Philadelphia Onshape user group leader. I founded MKCAD a long time ago and now continue to support the development along with a small team of other Onshape mentors. And like outside of the first world, I'm a product design student at Drexel where I use CAD, including Onshape, in just about everything that I do.
Wait, so you use Onshape in your real life as well?
Yes, I use Onshape plenty.
Wow, very cool. I know that there's I know that Onshape is growing in the professional world. It's just a lot of people are still in like the generic, regular like SolidWorks realm right now.
Yeah. So in formal coursework at Drexel, a lot of the classes are taught in either SolidWorks or Creo. But as I work on my own projects and that sort of thing as a designer, I obviously have the freedom to work on whatever platform I want, so long as I'm handing things in properly. There are still obviously projects and stuff that I do in other CAD platforms, but at this point, my preferred platform is Onshape, and so I tend to default to do things in there.
Cool.
I have a video here about the first thing that I want to talk about, the Onshape Teams workflow. One of the biggest things that I see FRC teams struggling with is how to organize their entire team. Maybe they have one document with the robot and one document with their robot card or their off-season project or whatever. they struggle to share it with the entire team. Unfortunately, I don't think that the video of this is going to play, in which case I'm going to kind of talk through it a little bit. I'm going to go ahead and mute that there, and I can kind of talk through it. But right now what Cody is doing is he's creating a demo of how to create an Onshape team. And an Onshape team, the best way to imagine it is kind of like a folder. That folder has its own sharing permissions. Teams, in my opinion, is one of the best workflows for FRC because you can add people, you can create admins and that sort of thing. And as the membership of the team changes due to the nature of folks graduating or staying on or becoming mentors or whatever within FRC, it's easy to add people, to remove people, to change their permissions, and it does so for all of the documents in the team. I currently am part of a couple of different Onshape teams, and we also use it for my Onshape 101 classes, which makes life easy to store a lot of documents and then easily share everything with everyone in the team. Then you can also, of course, go back in and adjust the entire description of the team, the name, just helps to simplify folks' workflow a lot. Right now, what Cody is doing is showing that the Onshape team should exist like right there once you've made it, and everyone that you've shared it on will be able to find it right there, as well as kind of a list of the other teams. Um, I'm going to pause it. Oh, this is how you share things. So once you've created a team, that tab will show up right there, and you can share, you can edit your permissions and share stuff with the entire team rather than individuals. It's a really like simple thing, but a great thing that Onshape put out not too long ago that helps to make the sharing process for teams a lot easier. Now for kind of the bulk of what I'm going to be talking about today, the first is FeatureScript. For those that don't know, FeatureScript is basically the programming language that Onshape developers internally write the features in. The features that exist like extrude or fillet or loft, they're written in this language. They're written, written in this language called FeatureScript. That language has been publicized and released to just about everyone. You can go find it online right now. And if you take the time to learn that language, you can develop tools and features the same way that features exist, actually inherent in Onshape, to make your design process easier. There are a lot of first specific design tools. There are a couple that I made years ago. There are some that I'm actively working on to make people's lives easier. There are also a couple of others that other people have made that are really incredible. Those features include hole pattern tubing, chain paths, pocketing, gear and sprocket profiles. There are even features that exist to create entire mechanisms. It's a really incredible space where folks have simplified entire design processes and kind of automated things that they tend to do over and over again. So for example, it's very, very common in FRC that folks use 1x1 or 2x1 tubing with like hollow tubing with a wall thickness. They put a hole pattern all across it. Julia Schatz created a feature that takes a simple rectangular prism and flips that entire thing into a hole pattern tube. It sets the name properly for your bill of materials. It sets the weight, it sets the material, it sets all of that stuff, and creates the geometry of the hollowed out tube and the hole pattern within it. In my demo later on, when I create the West Coast Drivetrain, I'm going to demo that feature as well as a couple of others that really make folks' lives easier within Onshape. And what's nice is that these features continue to come out. There are a couple that I'm working on right now that I have a bit more time on my hands, and really just a great search of Chief Delphi or even features that other Onshape users have made can do a lot to speed up your entire Onshape design workflow.
And real quick, Marcus, are you gonna show us how to access these FeatureScript tools? Because I'm guessing Onshape isn't. There's no just button that's like, make a sprocket for an FRC robot just in the general interface, right?
No, but those documents are public. And so in my demo, I have most of these features in my Onshape as well because I use them frequently. But I will do a quick demo of how I would pull in a public document and where to find the ones that I'm referencing if you want to use your own in your own documents.
Great.
The second big thing I'm going to talk about today is the MKCAD parts library. MKCAD is something that I started several years ago at this point, and it was when Onshape was first starting to come out. There was a frustrating workflow where when you wanted a COTS part, a purchased part from a common supplier, you had to go onto their website, download a step file, import that step file into your document, and oftentimes the features weren't quite right for Onshape, or it was built with different geometry. Then you had to go in, you had to set the weight, you had to set the color, you had to set the material, you had to set the name properly and all of this stuff. I often, when I was first getting to know Onshape, spent a lot more time setting up my COTS parts, which I like to use frequently as like a simpler designer. than actually designing the things that I wanted. Starting, it might have been in 2017, maybe 2016, I began to develop MKCAD, which is a parts library of just about every common part that I could think of, from Vex, from Rev Robotics, from AndyMark, from a ton of suppliers that are out there that are creating parts specifically for FRC or parts that are commonly used in FRC. Um, it's a really great space where like that simplified the entire workflow for me and for literally thousands of Onshape users that do stuff for first,
Yeah.
where rather than importing parts, you had to download them from the AndyMark website and then import a step or whatever. It like adds a couple of unnecessary steps that tend to be pretty complicated. You can just insert from this parts library that exists. What's really nice about that is it makes the workflow a lot faster, obviously, but also you know that these weights are right. You know that the colors are right. You know that the geometries are right because we set up this stuff accordingly. And frankly, they're being maintained by folks far smarter than I am who are paying really close attention to the new parts that are coming out and how to keep them as up to date as possible within this platform. Another thing that I want to highlight is not necessarily part of the MKCAD parts library, though it is a parts library, and that's Onshape standard content. Onshape added standard content, I believe, in 2018, and it's, I think my best way to explain it is a simplified McMaster catalog with far less to offer, obviously, where Onshape users can grab standard content, nuts, bolts, other fasteners, whatever, things that are standard in nature. So a 1032 bolt always has just about the same dimensions. Onshape is added in a platform where folks can pull that in. They can edit the configurations. It's a really powerful tool and just makes life easier because those fasteners are right there and easy to pull in, rather than someone sitting there and adding every little fastener into MKCAD, which I did do several years ago and then was made totally obsolete by this standard content. The last, or not the last thing, but one of the other cool things about MKCAD is the specific details of the product. So sometimes when a supplier releases their CAD model, they've developed it in another CAD software, or simply the model that they've put out is exported from their original CAD software, and so the details are not quite optimized for Onshape. Maybe it's something that should be one part so that it's easy to put into an assembly, but instead it actually pulled in as four different parts, so you need additional features to pull it in. Maybe it's that the weight wasn't quite set right when you pull it into Onshape. All of these details are being maintained, and as problems arise, say someone realizes that one particular sprocket, like deep in somewhere, was not quite set, or the color is wrong, or whatever, we can go back in and change that on our end. It takes me about 10 seconds to do that on my end or on the end of the other Onshape or the other MKCAD developers. And that will update across the board on everyone's Onshape accounts that are using these parts. One other thing worth highlighting is configurable components. I still don't know how to do this in Onshape, but I'm grateful to the team of MKCAD developers who have put in configurable components within MKCAD. So the initial workflow when you put in, say, a gear, I have gears configurable right here, is you would pick the gear that you wanted based on your geometry or whatever, and say I wanted a 42 tooth gear. I would pick 42 tooth, and I would drop it in. Say I found out later I need to change it to a 48 tooth gear, I would then delete it, or I could do the replace instance, but more likely I would delete it. Then I would go back into MKCAD and grab a new 48 tooth gear and mate it as on its own. One of the MKCAD developers developed a series of configurable parts. That means this MKCAD gear is configurable, I have bearings configurable, I have spacers configurable. They're configurable parts where, say, insert the 42 tooth gear and I realize that needs to be 46 tooth. I just right click it and change the configuration, and I can change it. I can add in the Versa keys, I can make it pocketed, I can do whatever I want. I can make these changes in the assembly without changing the specific instance of the part that's being pulled in. Makes for a much simpler iteration opportunity, and then folks don't need to worry about like putting in the wrong thing, then they have to go back in and grab it again. That's especially common with configurable versaplanetaries, which is up here, but it looks a little broken. I bet that it does work in real life though. Configurable versaplanetaries, that's a common thing that teams are swapping out. Maybe they want to add an encoder stage, or they want to change 7 to 1 to 3 to 1 or whatever. That's configurable. So rather than setting up your entire versaplanetary model again, on the back end within the MKCAD studio, it's handling all of that. So with a couple clicks, you can just flip it and do all of that stuff. Um, I
And
think that that's the end.
and,
Yeah.
and real, real quick, I wanted to sort of ask you. So, again, like for those of you who may not know, I'm not a CAD master myself, although I'm relatively fluid in it. So, these configurable components, how do they compare to say just like a model with configurations in like SolidWorks or a more traditional CAD system?
I would say that they're fairly similar.
Hmm.
My understanding is that even if you had configurable components in another platform, you would have to go back into the part file and change them.
Right.
This workflow is specifically designed within Onshape is such that in the assembly or in the part, of course, but in the assembly, because you don't have access to these specific part studios, they're like deep in Onshape land somewhere. You can change them within assembly, and you're only changing the reference to the original part studio.
Okay.
Yeah.
Another quick question here. So if you decide to change one of those configurable components, will it blow away all of the like the mates and constraints you've got going on, or will it try to save as many as it can?
Nope. It's going to, using specifically MKCAD configurable components, it's going to retain all of the mates and all of the constraints set up.
Oh wow.
These configurable components were designed pretty intentionally such that I'll give an example of the bearings. Bearings always have a mate connector on the, I don't know if my mouse is even showing,
Yep.
but
Oh yeah, we can see it. Yep.
okay, great. On this face right here, on the inside of the flange face, and on the outside of the flange face. Those mate connectors will always be in those three places, I believe, regardless of what mate you're using, unless, of course, you switch from a flange bearing to a radial bearing. The reality is that because those mate connectors don't change, only the parts that they're referencing change, the mate that you've set up to be a part of that mate connector is not going to change. And I'll do a demo of that when I hop into Onshape. I'll change from like hex to thunder hex bearings or whatever. All of those relations will remain. Except in there are probably some obscure, like complicated instances where they won't.
Mm.
But for the most part, configurable stuff will retain the same references and mates.
All right. Cool.
All right. I think that's all that I have for this stuff. So I'm going to hop in a demo here. Here's my last slide in the PowerPoint. We'll do questions at the end, of course, but please feel free to ask them. I have plenty of time at the end. This demo is not going to take that long. And at the end, there will be plenty of time for me to actually demo stuff in Onshape that folks want to see or address your own questions about how we do things in Onshape or whatever.
Yeah. Um.
I'm going to hop over. Shoot.
Yeah.
Francis?
While you're sort of moving over to Onshape and getting all that set up, I'm guessing that you're going to go through some of the basic sort of ways that Onshape operates, right? Because it does have some pretty fundamental differences compared to something like SolidWorks with respect to how do things mate and how do things get together and what a part studio is and all that kind of fun stuff.
Yeah.
Okay.
So I'm going to start from the Onshape landing page.
Great.
So you'll see I'm going to do it quickly enough that folks that know Onshape aren't like sitting here bored, but at the same time, any viewers who are coming from a different CAD platform or are totally new to this CAD stuff in general should be able to at the very least follow. And if you go back and watch this recording after, it might be a good opportunity to slow down and understand my workflow and some of the other workflows a little better.
Okay.
So starting from my Onshape landing page right here, I want to create a new document. I hit this create right here, and there are obviously different options. Two things that I want to highlight within Onshape that are very underused in FRC are folders and labels. So you see that I have a bunch of folders right here, and folders are ways that I can organize my CAD files. So if I say make a ton of different documents for prototypes for the 2020 game, maybe you want to store that all in one document. It's fine. Maybe you don't, and you want to store them all in a folder in separate documents. Folders is a great way to do that. The other one is labels, just another organization tool. Frankly, I don't use them, although there are a lot of teams, there are a lot of teams that do, and it's a great way to help keep your parts organized within an entire team structure or in a professional structure. I'm going to create a new document here, and I'm going to call it RSN conference.
Okay.
And with this, what it's going to do here is create a new workspace and create for me a part studio and an assembly studio. These are the two big studios that we work in. Part studios where we create parts, assembly studios where we create assemblies.
And
What
just
I'm going to
just
do,
really quick, just to make sure if there's anybody who maybe is totally new watching, just so everyone's clear, it looks like you're in Chrome, and you are actually, right?
yeah,
This is so the big thing about Onshape is that it's a cloud-based CAD software. I like to call it like something like the Google, almost like the Google Drive of CAD, where you can be working on it at the same time and have distributed, non-centralized, no heavy requirements for your computer or anything like that. So sorry for interrupting. I just remember that maybe I didn't make that clear when I started off. So continue. Go ahead, Marcus.
yeah, thank you for the context there. Yeah, Onshape was designed in the beginning by some of the members of the original like founding SolidWorks team, and
Oh, really?
they saw John Hirschtick, who I believe is the CEO of Onshape, but now that it's under PTC, has a different title. He was, I believe, the founder or one of the founders of SolidWorks, and a lot of those original team members started Onshape looking at the Google Drive model and seeing the opportunity. You'll see that this share the UI isn't familiar, but the way that it works is folks can collaborate live within Onshape. I should have put in my slide about like the perks of using Onshape or whatever, but the reality is that Onshape is designed very similar, like SolidWorks is to Onshape as like Microsoft Word is Google Docs.
Okay.
It's a really great space for that collaborative stuff. And so there are great resources on the Onshape Learn Center, the Learn platform, if folks want to learn more about that. I'm going to hop right into my demo here. And so you'll notice that I'm working in a parts studio. This is where I'm going to create all of the parts for this West Coast drivetrain. One of the things that's special about Onshape is you can create multiple parts, like the interface is designed such that you can create multiple parts in the same studio. That's going to allow me to build every single part for this West Coast drivetrain parts, or the parts that are not in MKCAD at least, in this part studio, and then I'm going to go in and pull them into an assembly and set them up nicely. What I'm
So
doing right now.
so
Yep,
when
go ahead, Francis.
when you're making these multiple parts together, is this so? I know that you can kind of do the same thing in SolidWorks, but they all live under one file name and they all kind of live together most of the time. Um, you're actually creating unique individual parts that you can address individually in an assembly as using a part studio. Is that correct?
Yep.
Okay.
So when I'm pulling things into an assembly, I can pull them from the specific part, or I can grab other parts that exist. I can do whatever I want within all of that stuff. So I could pull in the entire assembly studio, or I could pull in the entire part studio, or I could just pull in the specific part or the specific instance of whatever part that I want to grab in case I want to change the relations later on. Um, so what I'm doing right now is laying out the top view of my West Coast Drive, and I'm going to highlight the first, once I like check this sketch that it's done, and this is the geometry that I want, I'm going to check this sketch, and I'm going to highlight the first feature script that I want to highlight. That's called extrude individual. So I'll give an example. It's pretty clear if you know West Coast Drive architecture that this is a cross member, two drive rails, and another cross member. These are separate parts, and I want them to exist separately when I pull them into the assembly and stuff, because that's how we're making them in real life. Um, One of the frustrating parts about Onshape is if I want to go ahead and extrude this, I can extrude this cross member, or I could extrude that, I can extrude whatever. But if I go ahead and extrude all of them, or I just go ahead and extrude the entirety of sketch one as selected over here, it's going to select all of those features and filter the inner loops, but it's going to make them one single part. And I'll show what that looks like in a moment.
Oh,
This is with the default extrude tool. This geometry is not very helpful to anyone, and you'll see that it's all one part. So if I went to pull this into the assembly, I can go to the assembly studio over here. You'll see I have part studio. I could pull in the entirety of part studio one or just part one. That's just not very helpful to anyone.
right. Unless somehow somebody makes a custom extrusion that's just West Coast Drive, which would be pretty dope. But
That would be awesome. What I'm going to do here is delete the default extrude one, and I'm going to show the first of the feature scripts that I want to highlight today. Feature scripts, as I mentioned, are the Onshape language where folks can create features to optimize their particular workflow. So you'll notice on this bar of entire features, on the end here, I have all of the feature scripts that I work with. I work with a lot. I have made plenty of them. If you go to the bottom, or if you don't have any, there should just be a plus right here. If you go to the bottom of whatever list you have and hit add custom features, all of these features or all of these options will exist. You can go to public and search for features that I've made before. I think Marcus's feature scripts is still a thing. I hope so, at least. Maybe not. That's somewhere in this. Oh, Marcus's Playground is a bunch of feature scripts I made a while ago. A lot of the feature scripts we're going to be using today are in Julia's feature scripts. So this is a series of feature scripts created by Julia Schatz, who's now on the MKCAD team. And these features are like actively being updated and worked on right now. And there's some really awesome. The first of Julia's feature scripts that I'm going to highlight today is extrude individual. I'm also going to show tube converter and gusset generator. I might show a couple of other ones. I use several of these in my general FRC specific Onshape workflow. They're really awesome. So if you just click extrude individual or you grab that one, you'll see it's going to add to my toolbar, which puts it up there. I'm going to X out of that and you'll notice that extrude individual is now down there. It was also up somewhere in this list, but whatever.
Now, not to get too deep into this, but is Julia a first alum or is she an Onshape like employee or something?
Julia is a first alum. I don't know Julia's team affiliation
Okay.
or whatever, but first alum, active mentor, or involved in Chief Delphi or something. I should, but either way, putting out some really great feature scripts that I highly recommend teams use or learn from or whatever.
Nice.
They're pretty awesome. Extrude individual works very similarly to the default extrude tool, except it extrudes individual parts. So if I go ahead and click each of these right here, I'm going to set my depth to 2 inches because that's the height. It's going to create 4 separate parts.
Oh, wow.
That you can obviously see the difference from what it looked like earlier. And if you'll notice, if I go into the assembly, just to answer your question earlier, I can import or I can insert the entirety of Part Studio 1, as you can see here. They're not related, but they are together, so I could go ahead and group them. Or I could insert just that part, and it's going to do, again, it's going to put them in place related to each other, but I would need to set up the mates properly to actually facilitate that. The next thing that I'm going to do is I'll put in a simple belly pan just to go under there, and I'm going to do that just by...
Yeah, so as you're making all these parts in this part studio here, you're using the features from each of the individual parts to make the next one. Are there any like hard relations or mates being created right now, or is this just a tool to help you as you draw it?
So there are no mates that would transfer over to the assembly, but there are relations, and I'll show an example.
Okay.
If I go into Sketch 2, which is how I just made that belly pan here, that's the belly pan. I want that to always be in line with the edge of that drive rail and the top there. You'll notice that I didn't use any dimensions. I had Onshape infer constraints. So these blue constraints here are what Onshape is kind of, I set it up so that it will guess the constraints, but I could go ahead and delete these. And that's now free flowing, although it's centered with the origin. I can set these two to be coincident. That's what the coincident constraint right there, though I use the hotkey, and that point and that line to be coincident. What's nice about that, and of course this same logic will transfer over to other CAD platforms, is they're set up in such a way that if I go back in and, I realize that this needs to be 23 inches, I can then do that. And obviously, because that's dependent, just kidding, it broke because I set it up poorly.
Yeah.
But that's going to go ahead and change. I'll do another demo so that I don't look stupid on the air.
There you go.
That's going to guess and change, and it will do so across any configuration of all of this. That's not something unique to SolidWorks, but just part of my workflow for how I create things that are dependent on each other and that I want to make robust and scalable as needed.
You know, the thing that most surprises me and intrigues me is you're able to do that just by basically, when you originally made this, all you did is draw some rectangles and add a couple dimensions, and now you have like a fully sort of driven model without going through a whole lot of work.
Exactly. And you'll see as I kind of put in the rest of the feature scripts and that sort of thing, that this will continue to be scalable and robust if I need to make changes and stuff towards the beginning.
Okay.
So what I'm going to do now is make a new sketch, and I'll do it from the right plane over here. This is going to be kind of a side linear sketch of our West Coast Drive. So I'm going to lay out where do I want the wheels, where am I going to put the bearing holes, and that's going to help us figure out some of the geometry here.
Okay, so we're putting in the 1.1 bearings, pretty standard stuff.
I'll set the center to center distance between those, and we're just going to assume that it's whatever. How about 7.5 plus 0.18? 0.018 is like a center adder, so we don't need to tension the chain later on. And then I'll also set up the height to facilitate the wheel drop, say it's 332.
Okay. Oh, look at that.
The geometry will be a little cleaner. Obviously, that's going to go into the cross member. Maybe 8.5 works. That's going to work out nicely for us here. Although I'm now realizing that I didn't set up that.
So, yeah, you got to make the wheels same diameter. Okay.
Yeah. Either way, that seems about right for me. And obviously, I could have, instead of that dimension, I could do a midpoint constraint like that. That's
True.
a fun way of doing things. And then I'm going to mirror everything to the other side. So we'll grab those two. And I'm also going to, in this part studio, set up my gearbox mounting holes. I don't know exactly what those dimensions are off the top of my head, but obviously we can go change them later on. I think that, or why don't I mirror them first?
And so as you're doing this, I know you're using hotkeys and stuff as you go. So Onshape, despite being in a browser, has a full set of hotkeys you'd expect from a regular desktop application, right?
Yep. All those hotkeys are set up. One of the frustrating things that a lot of you can't customize those hotkeys. That was an intentional decision by Onshape, though a frustrating one in the opinion of many. Because it's web-based, they wanted people to be able to do things on different devices and be able to transfer over easily.
I see. So no matter what computer you're on, no matter what configuration or cookies you may have, you're just good to go with your learned dimensions.
Exactly.
Or your learned hotkeys, I should say.
Yeah. So what I'm setting up here now that I have this these bearing holes and my gearbox mounting holes, I'm going to do an extrude remove. So I'm going to cut out those features from the tube. And you'll notice, obviously, that I haven't put my hole pattern in any of that. That's going to bring me into the next feature script that I want to show, also one of Julia's shots. And I'll do the demo of how I would pull it into my Onshape anyways, although obviously I have it and use it frequently. So if I go into, obviously, add custom features, and I go into public and Julia's feature scripts, these are the same feature scripts that we had right here. I'm going to grab tube converter.
Okay.
What tube converter is going to do is it uses common geometry in FRC, 1x1 tube, and it's an entire single feature rather than the hollowing out whole pattern that accomplishes all of that for us. I'm going to select all of these tubes because I want them to have the same features. My wall thickness is going to be 0.125. My hole size is going to be 0.201. My 2-inch face style, I like the 1678 style pattern a little better, but folks can obviously do whatever they want. This feature was very well designed such that it's going to automatically sense the dimensions, figure out which sides are right, hollow out the tubes to whatever you want. You can set your hole patterns to whatever you want. I use 1-inch hole pattern typically. You can do your hole pattern like that. And obviously, again, it'll work on more complicated tubes. One of the things that's really awesome is, oh, this demo doesn't show it very well. This feature was designed such that, say, if this hole conflicted with the bearing hole, say that was 23 inches and it was in the middle, it will skip that hole. So it's going to skip geometry that will cause conflicts. A very well-designed feature that took, here's a great example. It skipped the hole that would be here and the hole that would be here because it conflicts with the bearing hole. Either it's too close or it would be inside. A very intelligently designed feature script that took a lot of iterations and is still being iterated. You can see there are a lot of options.
Is there an option to sort of increase the clearance around other holes in this dialogue, or is that part of the script itself?
I think that hole margin does that. So say I make that 0.25. I would like to think that it's going to get rid of those holes. Yep.
Bingo. Oh, look at that. Very cool.
So if I want 1/4 of an inch spacing around there, which frankly is pretty reasonable, I might leave that in there, and it's going to set up those holes. Again, these are all their own parts, and you'll notice from extrude individual, these are working properly. These holes are all very real, and again, as usual, scalable. So if I go back in and now I change this to 22 inches, this is a robust model that we've designed in such a way that it's going to make all of those changes. It might take a minute to load because it's calling on feature scripts and other things, and I'm obviously hosting a webinar right now, but all of that stuff changed, and the features still remain. My bearing holes are right, dimensionally accurate, and all of that sort of thing.
Wow.
What I'm going to do now is demo one more feature script, also one that Julia made, and then we're going to hop over to the assembly and showcase some of the MKCAD tools that make this even easier. If I go in and I'll show another demo of pulling stuff in, so I go to public, so it's Julia's feature scripts. There are also some that are in MKCAD. We're like talking about pulling some of Julia's formally into MKCAD. These are just the ones that I would use specifically for this drivetrain context. And I do want to highlight that this is not the only workflow for creating West Coast Drive. I had a debate internally of should I just do a drive rail and then subassembly and then real assembly. There are plenty of different ways to do this and totally valid ways. There are also probably better ways to do this, and I'm happy to have those discussions, or people can ask in the Q&A about other ways that we could be accomplishing the same thing.
Yeah,
What I'm going to do now,
if you wanted to, you could create each individual rail in the Part Studio. Kind of, let's say you're more old school. If you wanted to, you could create each of them individually, like not related to each other, and then throw them all into the assembly and start mating if you wanted to, right?
Yeah, totally could. One of the things that I did when I switched over and started experimenting, there's a funny post on Chief Delphi from years ago about like one of the first things that I posted, and I did everything in Onshape the original SolidWorks way. So I had a ton of different part studios here, each of which had one individual part, and then the mates I set up in the same way that you would set up mates in SolidWorks. That doesn't quite make a lot of sense in Onshape, and so while I was teaching myself, I wasn't teaching myself the best way, and I don't remember who, but someone called me on it, and it was pretty funny. I've now pulled in the gusset feature script, and again, one of Julia's feature scripts. This is awesome. This came out pretty recently. The gusset feature script takes input of holes like this, and it will create a gusset across all of them, like pulling them together. It is really cool. I could change that to like 0.25. It'll make it a little smaller. I'll leave it there. I can set the thickness. And obviously I can change that to concave and it will like create cool geometry and stuff. Say I want to add that part in as well. I totally can. This is a really awesome feature script.
Wow.
This one,
I hate to interrupt you, but my team, we made about 1 billion gussets last year. A lot of them were custom or semi-customized. This would have saved my team so much time if we had done this. I think this is awesome. Sorry for interrupting. I just couldn't help but say that. Go ahead, continue.
All good. Yeah, this is really cool. You can set the material and it'll set it up properly and all of that stuff. You can set it up to concave, which I don't super understand yet, but I think facilitates like weird geometry around holes and other stuff. Ask me later. You can set up the thickness and do other stuff with it if you want. It's a really awesome tool. I don't think that this is as robust because it's calling these specific instances of the holes, and if I made this a bunch smaller and those holes cease to exist, then it wouldn't have those references, though it might be able to, and I assume that fixing that is in the works. If that even is a problem, it might not be a problem. What I'm going to do now is mirror this, mirror this part across to the other side, and then I'm going to go ahead and mirror both of those parts, and then we're going to go into the assembly to pull these in.
Okay. So generally, do you suggest people? I come from more of a inventor and SolidWorks background, right? So in those programs, you would create just the one gusset, and you'd do all this mirroring and stuff in the assembly, or you would or just place 4 components and constrain them equally. And you're doing all this here in the Part Studio. Is that like the way you would suggest teams or users do this, or is this just the way you like it?
That is how I would suggest that folks do this. I would suggest that people do or teams do entire mechanisms or subassemblies in one Part Studio.
Okay.
One of the missing features in Onshape that I do promise you they're working on, though they've been saying it for years, is there is no assembly mirror tool. So while you could obviously go into the assembly and you could like make one over here and one over there and one there and one, or there are obviously smarter ways where you could do that faster. I can't go ahead and mirror it in the assembly like I did in here. That's just one of the missing tools that they're working on. Onshape is still very new. I think they started in 2013 or 14. It's like a very small startup. They're working on it. It's coming, but it's just not there quite yet.
Okay.
One of the other nice things is obviously if I want to make changes, I like to do everything in a really robust way. And so if I want to make changes, those mirrors are obviously set up nicely such that if I change this one, it's going to change all the rest of them. And it'll continue to retain those when I pull it into the assembly. So what I'm going to do now is hop over to assembly one, and I'm going to go ahead and just insert the entirety of Part Studio 1. You'll notice, again, to answer your question earlier, I could just import Part 6 and this tube for whatever. It'll do that. I don't want to do that in this specific case. I'm going to go ahead and grab the entirety of Part Studio 1. And then rather than going in and mating like this to that and all of that stuff, I'm going to showcase Onshape's group mate. So if I highlight all of this, and you'll notice, obviously, when I insert the entirety of the Part Studio, it's going to not constrain them. There are no mates that are set up, but they are all in the right place. So I could go ahead and like move this because it's not constrained, but they're in the right place. So what I'm going to do now, rather than sit there and mate everything, is I'm just going to set up a group mate. These are now
Oh,
all grouped together. They're locked in. They're together, and it makes life a lot easier.
wow. Now, this I don't know. That seems too easy. It almost seems like it's dangerous to me, right?
Mhm.
Like, are there any pitfalls that you can fall into if you do something like that? Like, I don't even know what it was, but it seems like it was. I feel bad saying this. It seems like that was too easy, right? It should be a lot harder to put all those pieces together.
Yeah. There certainly are pitfalls with that, and I would say the first one is like, or the first potential issue is you got to set up your Part Studio properly.
Yeah, that's true.
If you don't set up your Part Studio properly or in a robust way, then things can fall apart as you change them, or simply you might group them in the wrong place. The next is the entire structure of your Part Studio. I saw one team share, a bunch of teams like just share their Onshape documents with me. Some of them follow up with an email. Some teams just like share their documents with me, and I take a look. I don't know why, but I don't mind it because it's like fun to look at these projects and
Yeah.
that sort of thing. And I'm happy to advise and critique from afar. I saw one team that they used a swerve module, and they put the whole swerve module in one part studio. The part studio was really well organized, but then they grouped the entirety of that swerve module. You don't
Oh,
necessarily need to be able to facilitate that rotation in your assembly. Maybe you want to, maybe you don't. But it would have been a lot smarter to create one group mate for the rigid stuff and one group mate for the stuff that articulates, and then create a revolute mate so that it can rotate between them.
yeah.
I've seen similar issues with a turret where maybe teams are, or where a team group mated the entire thing, and then they were wondering rotate because it could rotate in their part studio or whatever. These are obviously cases where you might want to do a little more complicated stuff, and there's obviously the functionality to pull that off. But for the sake of time in this quick demo, and again, I am operating at like fairly slow speed right now compared to how I would actually do this for the sake of this demo.
Hmm.
In reality, this entire thing might take me 5 to 10 minutes tops to pull off this entire West Coast drivetrain. I'm just trying to highlight a lot of the features and that sort of thing.
Wow.
What I'm going to do now is start to insert the stuff that we're going to grab, and I'll showcase MKCAD. When you go into your insert, obviously the same way that we inserted the parts that are in this document, I can grab parts from other documents. So say I could go into my Onshape and grab like what's up here that's fun. I can grab my CAD final, or no, my homework. This is my CAD final. I can grab parts from there and pull them in. I'm not going to, but I just do that to show that because this is designed around Google Docs, I have all of the stuff that I've designed or things that have been shared with me in the past, and I can pull those things into this assembly with their references, of course, remaining to the other stuff that exists.
And this is where folders come in handy because just like Google Docs, if you have every single folder or doc you've ever made just in your top directory, you're going to lose track of something pretty quick.
Exactly. And your teams, like I said, they'll show up as folders. I talked about teams. They'll all appear. So you'll notice I have my old team 1836, their design folder is here. My new team Alpha Blue. The entirety of MKCAD also exists here because I'm on that developer team. I have some a Robots to the Rescue project, some stuff for my Onshape 101 courses. I could go in and grab, I have to create a version, but I could go in and grab stuff from each of these and pull them into this assembly, though their references will still exist to the older stuff. You can also go public. So say I want to grab one of the awesome parts from 319's robot. They've made some really stuff recently, and I want to take inspiration. Oh, I don't even know what they. You would find out what they called their document, of course. Big Bad Dog. I don't know what it is. I think that's what their team is called.
That's their team name. Yep.
There we go. So I can go in here and I can grab they're nice enough to make their stuff public, and they've made some really awesome to take a look at their forklift or even copy that forklift for an off-season project or whatever.
Mm.
I can go ahead and pull that in, or I could pull in entire assembly. So I could pull in their entire robot assembly, which
might,
somewhere
yeah.
and
Now,
very impressive.
is that gonna blow something up if you do that? Not on their end, but
I don't think that it will,
okay.
but it is very possible. Onshape is operating somewhat slowly right now because I'm obviously screen sharing and doing stuff live. The reality is that I could put in part studios or assemblies and that sort of thing from any public document, including awesome public documents from good teams that are sharing their stuff
Yeah.
for reference or for copying, frankly. There are some pretty awesome resources out there. What I'm going to show is the workflow for bringing in MKCAD parts. If I go into my insert, go to other documents right here, and then public, I can search MKCAD space, space, dash, space, and then whatever I want. Say I want gears, MKCAD gears. That's going to show up in the public document. It's going to bring a lot of them because folks like to make copies, and that can be frustrating sometimes. I think that this is see, there's copy, 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 and sometimes it can be beneficial to use copies if you want to use your own parts, but it can also be frustrating because you're working on outdated models that maybe aren't perfectly updated or whatever. We tend to do a pretty good job internally of updating stuff as new parts come out. I want to pull in gears. I can go to MKCAD gears and pull in each of these gears. I don't think this is the configurable one, so you can see like the outdated model or the outdated way of doing things. What I'm going to do now is show how I would pull all of this stuff in for this. I'll show a couple cool MKCAD tools. I'll show a couple cool Onshape tools, and then we'll kind of wrap up the demo, and we're going to have plenty of time at the end for questions or live demo or what people would like.
Okay.
I'm going to start with MKCAD bearings. It's going to take a minute to load here, but once it does, I'm going to be able to pull in this. Oh, that's a copy. This seems to be the original. MKCAD bearings over here. There are two different options. Drop. I'll grab Thunderhex flanged bearings. I'm just going to grab one right now, and you'll notice, for instance, and that exists at the center point of the inside of that flange.
Okay.
If I change this to a hex bearing or whatever, that mate connector will still continue to exist. And so once I put this in, I will go ahead and change all of them to a hex bearing, and it's going to update all of them, but leave the mates still there. It's a fairly robust tool and pretty impressive.
All right. I can't wait. I'm looking forward to seeing this, actually.
Yep. I'll go back into MKCAD public, and I'm going to grab MKCAD.
So say for example that, like, let's say that you wanted to do this, right? If you wanted to, like, take the MKCAD sprockets that you find here and then sort of bring them for use in your team to create your own team's library that your team would maintain, so you wouldn't have to necessarily deal with finding all the copies. Is that possible that you could do that through the system right now?
Yeah, very possible. There are a lot of great teams. I know I get emails all the time leading up to build season of folks they could make a copy of MKCAD because they want to add their parts. I know there's one team that asked me if they could make a copy of MKCAD for their own team and then add in the parts that they always use. So they always use the same L brackets and other plates and whatever. They wanted to add not only COTS parts, but parts that they always use. I told them, sure, of course, do whatever you want. That allowed them to create those duplicates and make life easier for everything. So they can do that internally, but those references, so they just copy the workspace as a whole, but those are not going to continue to, the references are not going to continue to exist. So say we update things on our end, they would have to do the same update on their end if they care about keeping those updated.
Yeah.
This is another configurable thing, and I think chain was added. Yeah, bingo. I've never used that before, but I will try to do a demo anyways. This is a configurable double sprocket. I'm just going to change to 17 tooth and I'll pull it in. And I'll do a quick demo right now so folks can see of how I would change things on a small scale. So if I create a Revolut mate, I'm going to connect this to that. You'll notice my workflow is a little weird. Other teams might be doing it there, but what I'm going to do later so that I only need to once. If I go, this is like the indication for a configurable part. If I right click, or for me it's like a double click, this part, and I go into change configuration, I can then change this to 18 tooth I'll hit generate. And again, those mates and features will all remain the same, but you'll see that now this is, and that wasn't like a very dramatic change, but
Yeah.
that
But
is now
still.
an 18-tooth sprocket, and that mate stayed the same. That relationship is still there because they were very similar features across those. I'm going to grab, I'll put this bearing in again on the other side of that, and then I'm going to put in a wheel after that. I don't think we have a configurable wheels thing, although it's very possible that's in the works. I'm glad to be working with like an MKCAD developer team from other teams who are
Yeah.
continually doing awesome stuff. I'm fairly removed from it. I'm glad to continue to be part of it from afar.
How many folks do you have working on the MKCAD developer group right now?
I think it's 6 or 7.
Oh, wow.
Some of them are pretty well-known mentors from a, but they're pretty awesome. We have like a Slack channel and there's like a Trello, I think, where folks can request parts. It's a really awesome group of people, and I think that they get some help from current 1836. That's my old team. MK was for the Milk and Knights. Current
Oh,
1836 students as well. Although I'm not sure about that.
okay.
I apologize, but the point is that there are some really awesome mentors that are actively contributing, and they're as new parts come out, they're updating them or they're putting them in. It's a really great group of folks that are very smart, putting together awesome resources. I think that this is all that I want to do for the wheel assembly right now. I suppose I could do a shaft, but maybe I'll do that later on, and maybe I will. We'll see. What I'm going to do is I'll do a fasten mate to put this in place.
So Fasten is that similar to like any other mates in like SolidWorks or other software?
I don't. I would say fasten mate is, well, I'll explain the Onshape mate system fairly quickly.
Okay.
The Onshape mate system works on degrees of freedom, similar to many CAD platforms. So each of those different mates constrains different degrees of freedom. Fasten mate is the simplest mate; it constrains all of them. So if I create
Oh,
a fasten mate of this bearing to that tube, I can't rotate it. I can't do whatever I want. I can't do any of that stuff. But I think I created a, yeah,
oh
I
yeah.
created a revolute mate for the wheel. Revolute constrains all degrees of freedom except rotational on what I bet is the z axis, or cross or about or whatever, what I bet is the z axis. So I can then create those. The workflow is a little different from SolidWorks or other platforms, but it makes life a lot easier. I'm going to use what Onshape calls the replicate tool to accomplish the rest of the stuff. It's going to be a little wonky because I have to delete a bearing, but it makes for some really awesome and easy additions to everything. The replicate tool looks like this Lego up here, and it's a very powerful tool. What I'm going to do is grab this bearing, grab the sprocket on the inside, grab this other bearing out here, and then I'll grab the wheel. What the replicate tool does is it grabs the like on-chip features that you want to use, or it grabs the parts in an assembly, excuse me, and it's going to find similar features to the features that already exist. In reality, it finds identical features. So what this is asking is what faces to find a match in. So you'll notice that it's created a blue circle around there. That's the feature that it's working with, or that's the geometry that it's working with. So if I
Okay.
click this face, it's going to find all identical geometry, the 1.125 bearing hole, and it's going to replicate all of these parts along there.
Wait, so
So I'm going to select,
it just found that? It just like there's a hole similar to the one that you just told
yep,
me to look at. I'm just gonna populate this down the line.
bingo. So if I click this face, it's going to replicate it all throughout that face, only on the geometry that matches. So I could also select this face, and there's no matching geometry, so it's not going to do anything.
Okay.
Um,
Wow.
Very powerful tool. Teams use it to put like rivets in the bottom of their belly pan. Just going to find all of the correct ones and put them in. It's pretty awesome. Speeds up my design process a lot for sure.
You know, as you say that, I think about it. I very rarely use. My team very rarely puts fasteners in the models. Well, I say maybe a handful of fasteners, but doesn't do when there's lots of them to just save time or what have you. And this is like super simple to make that like reasonable and something you could do in literally just 2 clicks.
Exactly. So I can the belly pan with rivets, or but teams are definitely taking advantage of this. And what's awesome is that these are not related to each other. They're making their own independent instances and mates. So you'll notice what I just did was, because a gearbox is going to go here in a minute, I went in and yeah, I went in and I deleted this bearing. So you'll notice that this bearing exists. I have it in the part studio here, but it's independent of the other bearing that's up here. It's independent of the other bearing down here. I can delete it. That's
Okay.
going to delete the rest of the mates. And obviously I could have set them up in a smarter way where it was based on this one, but whatever. I can now mate this, and obviously this is totally independent of the other. It's their own features, their own instances of the parts, their own mates. But I can also then go into a mate that was created. I'll pick a random one, and I can set an offset of 1 inch. I can flip it. I can do whatever. And it's only going to make that change in that particular instance. So it's not creating things that are dependent on each other. And it's very robust if I want to make changes later on. That's what the tool is designed to do. It's
Wow.
creating new mates and new instances so that, say I want this middle wheel to be, or say I want the outside wheels to be, I could change those, but the rest of the mates or whatever continue to exist as they would.
So while we're on
Very
this,
helpful.
while we're on this quick topic here, we're still getting questions in the chat, so keep sending them in, guys. We've got a whole bunch stacked up that we'll promise we'll get to, but this is prescient right here. Nuttyman54, he's asking, is the replicate tool like an assembly pattern tool in this respect?
I would say that the replicate tool is like an assembly pattern. There is actually an assembly linear tool. The difference between those two is that those relationships don't still exist. So I'll do a quick dummy example here, and I'll set up a linear pattern of this. I can pattern this, of course, but it's not going to create a new tube independent of that one, and it's not going to mate them. So I
Okay.
have the feature somewhere, linear pattern. It's not creating a new tube. It's not creating a new. Well, it kind of is, but it's only there based on the other ones. If I delete the first one, it's going to get confused.
Yeah, it's dependent upon your first tube.
Exactly.
Right.
The replicate tool is different because it's creating new geometry via new those parts, whether it's pulling them from MKCAD or your own document or whatever. And it's also creating new instances of those mates, which as needed.
Yeah.
What I'm going to do now is I'll insert the gearbox and I'll show another. Oh, I just went into my MKCAD gearboxes. We're going to find a gearbox that I like, and then I'm going to go ahead and put it in. I think that some of the gearboxes, not all of them, but some of them are also set up to be configurable. If I remember correctly, there's a West Coast Products one.
And so all these models were created by the MKCAD team, right? These aren't, they're from the models generated by West Coast Products that they put on their website, but you guys all actually made them, put them into Onshape and did all the constraining that needed for that particular subassembly, right?
Exactly.
Okay.
And so, oh, that was actually a mistake, but yes is the short answer to that question. The workflow on our end is we'll download a step or we'll download a supplier, publicize their stuff, and then we will set up all the parts and the constraints and the weights such that it makes life easier for you on your end. The configurable stuff is very complicated on the internal end. I mentioned earlier, I don't know how it works, but it's really awesome. All of that stuff is set up internally, and one of the upsetting parts is if you needed to make a change, say you needed to add a hole to a sprocket, that's a common thing for like arms or whatever. The way to do that is a little more wonky. But yes, all of that stuff is created internally.
Okay.
Is designed to make life easy for all of you watching.
And so you mentioned weights, and so from what I understand, what I've used it, there's not any like material density to like weight calculation in Onshape right now. Is that still the case? And so that means for all the MKCAD parts, you guys have weighed them and given them a fixed weight based on that unit, right?
Yes.
Okay.
Most of the MKCAD parts are a real life material, right? These wheels are, this tread is made from whatever tread is made of. And so we can go ahead and set the density of each of the parts based on the material, and it'll calculate the weight based on the density and the volume. And then we're going to go back into the actual Onshape thing, and we'll change the density based on, or we can make minor changes if the weight is significantly off from what's measured by AndyMark or cost supplier. One thing that I do want to highlight here is that the more complex stuff in MKCAD is also occasionally configurable. So in this particular case, this is a new gearbox from West Coast Product. I can change the configuration just like before, but rather than replacing all the part as a whole, it's going to make changes to the individual parts in this. So I could change these Falcons to mini sims, and it's going to make all the necessary changes. And I can change the first stage gear reduction to that, whatever it may be, whatever you would actually be using in real life. And it's going to make those changes reflected on the CAD, of course, without
Wow.
changing the original meat connectors that exist. So I could change those in place as well, of course, or not. Just one way that we are making life easier for folks. I'm going to go and mate this guy in there. I have to flip it a little bit. Bingo. And then I'm going to copy that and I'll replicate it to the other, or I'll copy it to the other side.
Okay.
You could be using the replicate tool here, but I don't really want to. While we go, I wonder if we have any other questions from the chat.
Yeah. Oh, yeah. We've got lots of
specific stuff.
Yeah, we got lots of questions here. And so this is kind of we're getting to this point where we might want to ask this one. Our CISC 101, the first question we asked today is,
Hey, Rick.
Yeah, he said Onshape gets really slow when there are lots of parts in an assembly and you're trying to do the mates. Any tips to help with that?
I would say the big one is be smart about what you have open and simplify your geometry. My crappy answer is that Onshape runs fine on my machine. My better answer is that Onshape is storing everything in an AWS server. So it's more related to your internet access and connection rather than your, rather than the hardware in your computer.
Well, okay, actually, because he also asked another question. Would you recommend a reasonable configuration for a computer to run Onshape? What's the way to beef it up? With memory, an SSD, a graphics card, or it doesn't matter?
Nothing. Doesn't matter at all. I've designed entire mechanisms for phone. I often in high school, like while I was driving home with my parents or a friend or whatever, pulled up whatever my teammates were working on, design reviews from Onshape Mobile on my phone using my cellular data.
Wow.
I'm running a pretty mediocre MacBook Pro right now, and Onshape is running totally fine. The entirety of this data is stored in an AWS server somewhere, and it's your web connection. I think that there are some improvements that you can get from computer hardware, but the system was designed such that you could use it on Chromebooks or whatever other simple platform, Mac, PC, iPad, whatever you want. It's all happening in the cloud, and so like beefing up to an incredible graphics card that I don't even know what it is not going to make significant improvements to your Onshape modeling stuff, though your web connection will. Simplify your models. The biggest mistake that teams make is when they put in electronics components, they put in the default electronics components that cross the road or first or whoever is put out. Those components have a lot of very, very inner geometries, and it's understandable why that would slow down any CAD platform, frankly, Onshape especially, more so than other platforms. One of the things in MKCAD, I'll show a quick example here, simplified electronics. Maybe it's just electronics. We've created very, very simple electronics. As possible. I think they're in here. So that you'll notice that I have simplified RoboRio.
Oh, okay.
It's just some text and two dots or two rectangular prisms versus the entire RoboRio is somewhere. That's a very complicated model.
Yeah.
That and complex curvature or weird geometry like that are the big down. Just be smart about what other stuff you have open and try to dedicate as much like if you're watching Netflix while you're working on your model, or obviously your process is going to work slower.
Yeah.
I still all the time hear and have my own complaints when an entire robot assembly is happening. When you're working on a very complex project, they're working on it, they're improving. Onshape is still continuing to scale up, especially from their recent acquisition by PTC. They're continuing to scale up, they're continuing to get better, and they're they're working on it, but
Yeah.
it's tough for sure.
And again, I'm not a CAD master, but I did used to in my previous job I was a document control coordinator, and I used to do a lot of stuff in the CAD library for my old company, Symbotic. And so one of the other things that teams may want to just take a look at is there's also ways you can maybe fix things up by using more simplified versions of hardware, right? You got to ask yourself, does your screw need to have threads to make the model work, right? And especially if you've got lots of screws, you can go that route. And the other thing, the biggest challenge is, like you were saying, first models have a lot of features you don't need, like the particular pins on the Robo Rio, but especially stuff you may download from McMaster-Carr or other STL files tends to have very dirty geometry on the inside that isn't super great. And so for those things, you want to double check, optimize, or just make a more generic model if you can get away with it.
Definitely. I would also advise hesitation to work with STLs or other mesh models within Onshape.
Yeah.
Onshape is designed around parametric stuff, and so pulling in the step, pulling in a SolidWorks part, pulling in that stuff tends to be very easy. Pulling in a complicated STL with weird meshes and other things, one, just looks real crappy in Onshape, but two, is going to slow your machine down a lot. Try to default to using steps, and I would even recommend, if you're having a lot of trouble with a complex STL or that sort of thing, it might even be worth opening up your STL in SolidWorks, in Inventor, converting it using their tool, which I will say is superior to Onshape's in my opinion, and then pulling a step or solid part or IP to Onshape.
Yep. Does Onshape will accept? Will Onshape accept like a SolidWorks SD, ML, a solid model from SolidWorks file, or does it only want?
Yep.
Okay, cool.
So if I go to import here, I can show. I can't show, but yeah, Onshape will accept a SLDPRT.
Mm-hmm.
It won't accept a SolidWorks assembly because it has to have the references.
Right.
But if I do remember correctly, I think it will take a SolidWorks pack and go, which is the parts and the assembly, and then pull that into Onshape. The assembly won't translate quite right. The individual features won't totally copy. It's not going to grab the specific extrude and revolve and fillet that you grab, but I believe the geometry will copy over, and the assembly, at least left in place, will copy over.
Okay, cool. All right, so while we were discussing that, you put the other gearbox on the other side of your drive line. So now you've got a robot drive line with 4 motors, 2 gearboxes, 6 wheels, bearings and sprockets, gussets, frame rails, holes. The only thing you're missing is like the shafts and some chain and whatever hardware you would want to put on there.
I'll do 2 quick examples I'll do one show shaft. There are a lot of different ones. They are all incredible. I'll show Julia's feature script for chain, which again, I'm not certain it will work, but it probably will.
Now let's give it a shot.
And then I'll do a demo of the fasteners, and then at that point, we'll have plenty of time left to open the floor for questions.
Yeah.
Excuse me. Either about my Onshape experience or live demos. The first thing that I'll do is the shafts. There's one feature script that I still use today that I made a long time ago, and I call it the shaft. I call it shaft generator or something. What I'm going to do here, and the reason that I set up this entire assembly before I designed the shaft is because I wanted to grab that dimension. So you'll notice that I have this dimension here, that dimension there. That's what I'm calling the effective length of the shaft. So retention features aside, this is the length, and I've used the measure tool to grab that, and I copy and pasted it to grab that length right there. And I'm going to go and create a new part studio just with the shaft. You could be doing it in the same part studio. There are workflow reasons why you would or why you wouldn't. It's easier in this particular case just to put the assembly in. If I find shaft generator here.
And so actually, 90Man54 also asked, since you can put multiple parts in one part studio, how do you recommend teams divide up the part studios for a whole robot? Would you actually want to make a part studio that's got that wheel and shaft assembly, or would you want to make a part studio for all of your shafts on your robot or something like that?
In my opinion, the best workflow is to do each mechanism or subassembly in an individual part studio, but to get that to be as small as possible. So using an example from before, if you have a shooter on a turret, I would say do the shooter in one part studio and the turret in one part studio. Make an assembly of the shooter assembly, make an assembly of the turret assembly, and then pull both of those assemblies in a like shooter plus turret assembly.
Okay.
What that's going to allow is if you need to make changes to just the turret, you can make them at another level, and it's going to obviously replicate those later on if you need to make those changes or whatever. It's possible that here's shaft generator. This is a feature that I made a couple of years ago, and I think if you just search shaft generator, or you can find the link on Chief Delphi or other stuff if you want. This is not the most common, but one that I designed for my particular use case, so I like it. If I go to Thunderhex, I'm going to do the 1836 combo, which 1836 combo is basically the retention type, a snap ring, and then a nut, and then a bolt and washer on the end of it with like Loctite in there. We tend to be very conservative with that stuff, and so we decided that just a snap ring or just a bolt and washer wasn't enough. We tend to be very simple robots. We can certainly afford the weight and all of that stuff. When I was designing robots, I always made an effort to do both wherever I could. Then I'm going to add in the effective shaft length, which you might remember we copied from the part prior. If you notice over here, this length is what we want for the effective shaft length. That is that number that we copied before. And then the snap ring groove is dimensionally accurate to the snap rings we typically use from McMaster. And then this probably should be a 0.201 hole, which that we could then grab and do all of that stuff.
So that's a clearance for a 10, I assume, or an 8?
That's a tap hole for a quarter 20.
Oh, okay, cool. Yeah. Got it. I apologize. So my team hasn't used a quarter 20 in years, so I'm like not down with quarter 20s at all. Gotcha. I don't remember any of the numbers.
So our standard hole size on 1836 1, which is quarter 20 tap, or it's a little bit oversized for 1032 through hole. So you'll notice just gives us a little more clearance, a little more wiggle room. We also use it for rivets. I don't even remember what size, but it's a common hole. It's number 7, I believe. That's what we use very often. So I'm going to go ahead and I'll make that in there. I will use the replicate tool again just to make our lives easier a little bit. You'll notice if I pan over to the other side or rotate over, whatever, that's exactly right. That's where I want it to be. I actually should have done the snap ring on this shaft so we don't have to put it all in again. One of these days I will go back into that feature and I'll put the snap ring and the retaining and the bolt actually in there. But
because this is an excellent application of like using the part studio and using the one I forget what it's called offhand, the one button mate to everything, the fix mate.
Yeah. What is it called? I think it's shaft retention is what I call it. And in there I should have snap rings and my. But yeah, again, one of these days I will actually make that change. Here's a 1/2-inch snap ring. And you'll notice in most MKCAD stuff, we actually have the part number in there. So it's there for reference in your bill of materials. You could also then go into McMaster, copy that specific part number in case you needed to buy a bunch and you don't remember exactly what you have. And that's my bolt and washer that I like to use. Kind of a bit of a simplified model. I still have the threads in there, but they're like designed intelligently.
Mm-hmm. Yeah, not to derail this, keep going. But when I was working at my old company, we used to make very, 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 very large structures. Like people would try to make assemblies in SolidWorks that were of a thing that was 6 stories tall and hundreds of feet long, and then they would insert hundreds of fasteners to assemble the thing, and then they would complain when SolidWorks kind of crapped out on them. It's like, well. Yeah. You are doing something that's pretty crazy, but yes.
So yeah, I made this feature script a long time ago, so a lot of names they aren't set because I made this before the thing that you could do in feature script. One of the awesome things about Onshape is that these things are being updated constantly. In a minute here, when I do the chain, I'm going to show one thing that Onshape added like a week or 2 ago. Oh. Every 3 weeks, Onshape adds new features, and part of the nice thing about this web-based platform is that they go in automatically. So you don't need to make changes. You don't download a new update. You don't download Onshape 2020 or whatever. every 3 weeks, Onshape dev team will release a new feature, and it's just going to show up in your Onshape, and it's going to work well. And
Wow.
obviously, there's stuff they do internally to make sure that it continues to work and doesn't affect anything that you already have.
Yeah.
But like,
Uh,
yes,
is there like a beta branch or anything if somebody wants to be on the bleeding edge of Onshape?
there is somewhere. I know, like, if you go into your, I don't know the details of that program. I would recommend doing a quick Google search or
Mm.
whatever. Onshape does a very good job of handling things. A lot of the Onshape developers and Onshape employees are first alums. And
Oh,
so something that's pretty cool is one of the things that I would bet they tend to do internally is some of the stuff that they test their new features, their new adding things on are folks that are things that these folks worked on in high school, FRC robots.
yeah.
Um, by no means is Onshape being designed around this stuff. It's like a real consumer platform that exists in real life, of course, and there are a lot of professional companies that are using it. But a lot of those same tools are being like worked on for first, and you'll notice with Robots to the Rescue, other amazing stuff that the PTC academic team is doing. A lot of those people are first alums. A lot of those people care about it a lot. I made a post on Chief Delphi like a couple days ago that was like, not gonna lie, can't wait for 10 years when the entire workforce only knows Onshape because they all came from FRC. That's what they're doing. It's a very intentional decision to put a lot of stock and care into first, because as continues to scale, continues to get better, continues to improve, like they're the first teams, the people in education, these will be the people in the workforce, be the people running the show and doing the actual in the field. What I'm going to do now is, now that I've finished up the shaft, I put all of that stuff in. The way that I did it was a little crappy, but it was fine. What I'm going to do now is show one of the new Onshape tools. I think I can grab it in here, called Make Transparent. All that's going to do is make this particular part transparent so that we can put in the chain for these sprockets. Again, I have not actually done this before, but I would bet that it's going to work. I just made that transparent. What I'm going to do now is I'll go into MKCAD, and we had chain and sprockets in there before. Maybe it's called sprockets and chain.
While you're doing this, we have another question coming in from the chat. They're asking, what's your preferred method for version control when it comes to this stuff?
Certainly not my area of expertise.
Uh-huh.
And one of the big reasons for that is because I'm obviously an alum from First, and I'm a little bit removed from this stuff. A lot of those tools were made like after I graduated, and so I've been a lot less involved in design, designer type thing. Where was I go? Oh yeah. I would suggest that you and anyone that has questions that go to the On Learning Center, and that's going to be a space where they have a lot of the tools to learn about versioning and that sort of thing. I kind of just make a version whenever there's something that I want. I don't know a lot about the version control stuff or what's going on with that behind the scenes. I would say make a lot of versions. It's nice to have stuff for like your own reference and that sort of thing. I don't have a specific workflow to recommend for that.
Okay.
I would just say make a lot of versions is my like bad answer.
Yeah. And versions are supported in Onshape, right? You can draw a line in the sand just like in Google Docs. You can do that.
Yeah.
Yeah.
I'll do a quick demo of that after I wrap up this. What I'm doing right now is you'll notice the from MK, and that's in like MKCAD sprockets and chain or something. But what I'm going to do is I'll grab that cylindrical profile, and I'm going to grab this one, and what it's going to do is tell me the exact center to center. I don't remember exactly what I said it. I could, of course, go back into the sketch, but it just told me down there, and I copy and pasted it. I'm now going to change the configuration of this so that the center to center distance is exactly what I want. I believe the sprockets are 18 tooth, and you can also change from simplified to realistic. I want to see what the realistic one looks like. But that'll load up in a minute. Obviously, the realistic one is a little more complicated. I also don't know where it went. How about we stick with the simplified one for now? I'll generate this, and then I'm going to check to insert it. It's going to load up in a sec. And then what I'm going to do is in there, I'll use these mate connectors that exist. And again, those mate connectors, just with the rest of MKCAD, were very intelligent set up such that if you need to make changes later on or whatever, you totally can. They're very robust. It's going to make your life very easy. They're pretty awesome tools. I'll do a cylindrical mate, all of this. And then I'm going to do another one to the other sprocket. I'm just going to do one of those because I think it would be a little stupid to sit here and do all of them for the purposes of this demo. I'll do a quick demo of Onshape standard content, and then at that point, we'll open the floor for plenty of questions and other stuff that folks want to talk about. Throw this other guy in there, and I'll mate it to the center of that.
There you go.
Yep, and that's going to be right in place. I will set up one more planar mate just so that it's in the right place, like the actual sprocket run. And there we go. You could obviously go back in and do that for all of them. I'm going to make this now untransparent demo of Onshape standard content. That's going to take me a minute, and then we'll open the floor for questions. So please keep those coming in.
Yeah,
I would love to answer as many questions as folks have.
Yeah, we have a few in storage over here. We're kind of waiting for a more quieter time to talk about them. But go ahead.
Gotcha. Awesome. So if I go to the same insert right here, current document, the last option is standard content. As I mentioned, this is kind of hardware, common stuff that exists, and there are tons of different options. I had this open right here before. What I'll do is a quick example of how I would pull in a nuts and bolts to mount these L brackets. I'll replicate them across the rest of stuff, and then we'll wrap up by talking here. I'm going to grab 1.75. I think that's the right dimension here. It might be a little long, but I'll do 1.5. And I'm going to hit insert. Onshape is designed this so very similar to MKCAD and S. A mate connector that always exists if you need to make changes, and that's it's a little more integrated into Onshape because it was actually made by the Onshape developers. As much as I may like, they're not going to let me put MKCAD into the actual Onshape stuff, but the current workflow will suffice. What I'm going to do now, I have this nut, I have this bolt. I'll set up a fasten mate with them, and I'm going to set 2 plus 25. These are inches. One of the cool things about Onshape, as well as many other CAD math, then you can also work with other dimensions beyond the original, beyond your whatever.
That's one of those features that when I found out about it when I was first learning CAD, that you can just do the math in the CAD software. It added a huge it was a huge sigh of relief for me.
Yeah, it's awesome. And you'll notice here I made a 1.5 inch bolt, which is simply wrong. So 2.5, maybe that. Math is difficult sometimes. That looks like it's right enough for what we're doing. It also looks like I made a ridiculous nut choice, so I'm going to go back in, and again, I'm right-clicking there, edit standard content instance, and yeah, that's a 3/8 nut. I'll change that to 1032, which is what we had before. I think it just defaults to whatever the last one you used is, so I was working on a CAD model earlier, and now I have this guy here. I'll create a fasten mate of this to one of these guys. And then just like before, let me make sure that it's right with the nut. That looks fine to me. I'm going to go and I'll use this replicate tool. It's the guy that looks like I want to replicate the both of those there. Faces to find match in. I'm going to have it find a match in all of these L brackets. It's going to do the same. Oh, not quite, because I didn't set up. I apologize. I did a poor job setting that up.
That's all good.
What it just did there was it was looking for similar faces to this arc rather than that hole.
I see.
Not what we wanted there. If I do that, it should give me what I want.
There we go. Wow.
And so that's going to copy all of those very quickly. You can doing details like that, which can be totally grueling. I'm going to hide all the make connectors that we created before, and that's it. There are obviously other details that we could put in. We could make adjustments to shaft length. We could do other stuff, but I would say that this is a pretty solid demo of the MKCAD tools, how to shape workflow, and some of the awesome feature scripts that I and Julia and some other folks have made. At this point, I'm going to stop talking, and we can open.
Yeah. Well, hey Marcus, that was awesome. I mean, to see you just kind of whip out a robot drivetrain in like no time, with very few clicks, a lot fewer than I was expecting, is pretty amazing for me. I'm very impressed.
Thank you.
So we're gonna, like I said, we got some time for some questions here from everybody. So if you've got a question, just send it into the chat with ~Q followed by your question, and we'll be happy to put it on air and have Marcus answer it. So I'm going to give you, this is an interesting one right here, coming from user off and back on, and they're asking, is there ever a instance where you would not recommend using Onshape for a CAD project?
There definitely are specific times where I would not recommend. I would say that the two big ones are, well, I'll give context. One of the biggest perks of Onshape, as we've kind of talked about, that's why I highly recommend and preach, and I talk about it a lot for FRC. There are certainly things that Onshape has that other CAD platforms don't. There are certainly things that other CAD platforms have that Onshape doesn't, like Assembly Mirror, for example. If you need to do more complex modeling, Onshape is a great platform for, like, with a easy learning curve and for folks to get started, but it sometimes can be a little difficult to do higher level, more stuff. I think that Onshape sheet metal is still fairly lacking. I think that there's quite fleshed out. If you're doing work on your own or with a small team, still certainly recommend SolidWorks or other CAD platforms. There are times where I use SolidWorks for my own work, for professional work, for classes, or for whatever it may be. If I'm just doing stuff on my own, then in that case, like, other CAD platforms will outperform Onshape a little bit in some contexts. There was a post on Chief Delphi a couple of days ago in response to my, like, snarky thing about the Onshape workforce, about like, use of Onshape for government contractors and government specifically is a non-starter because Onshape hosting cloud, and a lot of companies have company policy where all of this data needs to be stored internally, for folks that are working at places where their data needs to be stored encrypted or internally or whatever. Maybe it's a government agency or whatever.
Yeah.
Yeah, like, Onshape data is stored in an AWS server, and, like, I don't know the details of that encryption or that privacy, but if that's the reality, like, Onshape is not at a level to, maybe that's coming. It might not be. I don't know the details of what Onshape is, but I would say that those are the two big cases. If you're just doing stuff on your own, more complicated modeling, or stuff where you need to store stuff on your own server, those are the two big ones. But specifically for FRC, especially when you're, highly recommend Onshape. Great opportunity for students to learn, great space for collaborative stuff, and it fits really well into an educational curriculum. And the Onshape team, as well as the PTC academic team, are working very hard to continue to create those resources to make life easy for you guys.
Well, that's actually a good segue into this next question we have here from off and on again. They're asking, for anyone who might not know, can you tell us how FRC teams can get to access Onshape education accounts?
Sure. I'll do a live demo. I hope that it's still screen sharing here.
Yes, we are. Yep.
If I go to onshape.com/edu, it's going to take me to the Onshape for Education landing page. And there are actually some great resources because of Onshape and PTC's Robots to the Rescue thing that's happening right now. There's some really great resources on getting started with Onshape for FRC beyond just the original stuff that's out. But if you go to, again, onshape.com/edu, it's going to take you to this landing page. Sign up for an Onshape EDU account. You don't even need an email. Your affiliation with First Robotics as a mentor, as a student, as a whatever you may be, they will give you access to the Onshape educational platform. There is also an Onshape free thing, which a lot of folks do, but I think it makes most of your stuff public. it limits a couple of the things that you have access to. Onshape for Education isn't quite the Onshape profession, but it accomplishes just about everything you would need to do for FRC anymore. So you go to that website here, you kind of fill out this form. There might be a little more stuff, and you don't even need the EDU email again. Just your affiliation to FIRST as a mentor or student will accomplish that. And sign up for Onshape Education. It's a really great opportunity and space to learn.
Great. So we're coming down to the wire here for questions. If anyone has any last ones to send them in right away so we can make sure we talk about them. This question comes from user Rob Orb 2017, and they're asking, are the feature scripts you labeled are the feature scripts labeled with MKCAD like the COTS parts are, or how would you make sure that you can find those feature scripts if you want to use them yourself?
So if I go to insert here, the feature scripts, oh no, it's in Part Studio is what I'm looking for. If I go to insert custom features, MKCAD does have feature scripts. There are a couple of really great ones. Tremblay made for sprockets. There's some other stuff that it does exist within MKCAD. Here's MKCAD feature script. There are a couple of them. A couple of them are ones I made. A couple of shaft generator. The one I demoed is chain path generator. There's a chain. Obviously, these exist. The other ones that I showed today are created by Julia Schatz, and we're debating putting those into MKCAD or not. Like that's a conversation that's actively being had now. But I'll do another quick demo of how you would pull those in if you really wanted to. So if you go to the plus right here, or in the drop down, of course, add custom features, public, you just search Julia's feature scripts. You should only need to ever grab those once, and then they'll all. This is the one you're looking for, and these are all the features that exist in that document. If there is a better way to access those, if we put them into MK, we change the name or whatever, suffice it to say that we'll advertise plenty via Chief Del platforms where folks often use.
All right, cool. And so we'll have one last quick question here. This is from NuttyMan54, and he's asking, I'd love to see an example of how you would import a sprocket or a gear from MKCAD and make modifications to it. How should you do it so you don't end up with MKCAD copy in the world to see?
Sure. I'll do a quick example, and the way to do it is the Derive tool in Onshape is a way where you can basically bring in other parts or other assemblies into a part studio for modification. So if I go into other documents, and again, I use the Derive tool, which is this guy right here. I'll go into other documents, MKCAD, sprockets. This is a very common thing that I'm going to show an example. Sprocket, and you want to put a big bolt in on the end of it. I'll do that here. Add sprockets and chain. I'm going to grab a 3/8 plate sprocket, and I'll grab the biggest, or 35 chain. I'll grab the biggest one that they have, just so we can show. Say I want to make an arm with this sprocket, and I can even pull the sketch in if I want to here. It's not going to pull in all of the detailed features that we use to make this, but it is going to pull in this geometry, and you can even grab the sketch to see the geometry that we use to make this stuff. Now that this exists in a part studio, that dependency on MKCAD does exist, but I can then create a sketch. Say I want a 3/8 bolt right there. Two and a half inches away, or whatever it may be. Great way. You can then make an extrude remove, make a cut through that, and it's going to put that hole exactly where you want. This part now exists in this part studio. It doesn't change the part in MKCAD, of course. The Part Studio 3 with this specific instance of the plate sprocket does exist.
Okay.
So I could go into Assembly 1 or whatever I might be doing, and I can grab this thing from Part Studio 3. Obviously, this is not a real opportunity to use it, but
that is a big sprocket. Oh my goodness.
That's how I would make those changes, and that's something that we did in 2018, I believe, on Team 1836. This, in my opinion, is the easiest way to do it. I think that there are others, but this is how you could do it. Yeah, I hope that's a helpful answer. And you can obviously see how you not just make a hole, but make other changes to the part after you've derived from MKCAD.
Very cool. Well, I think that's all the time we have. I think we got through most of the questions. Marcus, thank you so much for being here today. Even though I've like used Onshape a little bit before, I still learned a whole lot about the capabilities of the tool. And truly, I think that it's one of the best programs out there for specifically for first teams, just the way that you can collaborate with everybody else. If you've never had the opportunity to work on a CAD model while somebody else is working on the same model, it's actually pretty crazy to think about and to see when it actually happens. It's pretty cool. So cool.
Sure. Yeah. Thanks for having me, Francis. I'm glad to be a part of this. We'll open as I will open. Have more questions about it. They want me to design review their stuff. I get emails and Chief Delphi PMs all the time. I'm more than happy to contribute. I work with the Onshape team on a number of things, and I know this stuff pretty well. I'm grateful to a lot of mentors that I've had in the past that have helped me to learn this stuff, and I'm happy to return the favor, especially during this quarantine thing. There are a lot of people that are learning right now.
Yeah.
Don't hesitate to reach out via email, via Chief Delphi, via whatever you want. I'm happy to facilitate further learning and answer your questions and that sort of thing.
Fantastic.
Thanks for having me.
No problem, Marcus. All right. Well, for everybody here who's watching, stay tuned. We have our final conference presentation of the whole 5-day event coming up next. This is going to be an end of bag day roundtable discussion with Alan Gregory from Spectrum, Tom Bott from 254, Ty from 319, Evan from 4911, Emerson, the boss from 148, and Karthik, of course, from 1114. We're going to have that up in just a moment. I hope you guys stick around. And one big thank you to Marcus once again for being here with us. Until then,
see everybody. Thanks, everyone.
Yeah, see everybody in a few minutes. Thank you.
Is that there is no